Okay, hello and welcome everyone. Today we're going to get cracking on the whole topic of derivatives, differentiation, the tangent to the curve. And the best way to start is by looking at limits and continuity. Now these two are two sides of the same coin. They both go hand in hand. You need to kind of understand one to understand the other. In layman's terms, when I'm talking about a continuous function, it's just a function that when I take a look at the curve of this function, it's unbroken. Let's say something like y equals x or y equals x squared. And you'll be able to clearly tell when a function is discontinuous because its curve is going to be broken, something like this. Now that's a bit of an informal definition, so it's important to understand limits before we start formally defining when and where a function is continuous. So when we take the limit of a function as x approaches some value, let's say c, in general the answer to this in a question would just be the value of f of x at c. So you know what I mean, you just sub in the c value to the f of x and you get your answer. So let's say I took the limit as x approaches 1 of 2x plus 1. If this was a question in an exam, the answer would simply be 2 times 1 plus 1 equals 3. But there's obviously a deeper meaning to all of this. What we are trying to understand when we take the limit of a function is going back to the formal definition of the limit. Let's say the limit as x approaches c. What we are saying is that we are trying to find the behavior or understand what kind of value f of x approaches as x approaches c. And a lot of the times when we're trying to test for continuity, if we get a limit that the answer of is undefined, that kind of tells us that that function at that point is discontinuous. Something very simple is the limit as x approaches 0 of 1 on x. Now, if I was to solve this properly like we were solving before and I subbed in 0, well, 1 on 0 is undefined. And basically that identifies to me that at 0, 1 on x is not continuous. Alright, taking the limit as x approaches 3 of 6x plus 4. Now, we can see, there's a function here, f of x. X is approaching some value c, which in this case is 3. So, the limit as x approaches 3 of 6x plus 4 is just the value of the function at that point, which is 6 times 3 plus 4. Which is 22. Excuse my handwriting. Now, here's a bit of a tricky one. I'm sorry to get it going really early, but I feel like, to expand our brain power, we need to tackle harder problems. The limit as x approaches infinity of 1 on x. Now, the reason why this is a tricky question is because we're not given a number that x is approaching. But we know that infinity is big. It's very big. It's huge. When our denominator increases more than our numerator, our value is going to get smaller. It's just going to keep getting smaller and smaller and smaller. A simple way to look at this is 1 on 4 is larger than 1 on 8, is larger than 1 on 12, is larger than 1 on 16, etc., etc. All of these are smaller than each other. So how the hell do I come up with an answer for this question? Well, we have a 1 in the numerator. And we are saying x is approaching infinity. And infinity is massive. Infinity is huge. So this is getting smaller and smaller and smaller and smaller and smaller. Eventually it's going to go to the smallest number, which is 0. So we can confidently say the limit as x approaches infinity of 1 on x equals 0. Now, let me expand your brain even a bit more. A lot of the times, the limit, if you take it as it is going to be undefined. Take a look here at this little example. If I sub in x equals 2, the denominator is going to equal 0 because, 2 squared minus 2 times 2 is 4 minus 4. And that's 0, and it makes our limit undefined. But it can't be that easy. So the best way to tackle limits that are a bit more complex like this one is to first of all simplify your function, simplify your f of x or your y or whatever you like to call it, and then take your limit. So if I look at the numerator, it's a trinomial, and if I look at the denominator, it's easily factorized. If I take this limit, if I take f of x equals that function, and I'll simplify it, I'm just going to break it down for you right here real quick. If I simplify the numerator first, I can see it's a trinomial. So what adds up to 4 and multiplies to give minus 12? Well, quite simply, 6 and minus 2. Do we agree on that? So I can take the numerator and factorize it as x plus 6 and x minus 2. And the denominator is easy. I just take the x out and I also get x minus 2. And look at that. X minus 2's cancel out. And I'm left with x plus 6 all over x. Bring that all the way back to our limit. This limit just equals the limit as x approaches 2 of x plus 6 all over x, which is just 2 plus 6 all over 2 equals 8 over 2 equals 4. Here's another cheeky one just to test your knowledge of trinomial factorization. Just some more bang for your buck. We can see here we got another limit, but if we sub in minus 2, we're also going to get 0 on the bottom, and it's going to make our limit undefined. But the trinomial on top is quite a bit tricky, and there's no room for factorization on the bottom. But the bottom kind of gives you a bit of a hint of the kind of factorization we're looking for the top function. If I take the top function on its own, 3x squared plus 5x minus 2, this is just a standard trinomial. How do you solve this? Well, we multiply 3 by minus 2, gives us minus 6, and then we check what adds up to 5 and multiplies to give minus 6. Well, quite simply 6 and minus 1. So we'll break this down to 3x squared plus 6x minus 2. If I factorize this by taking the 3x out, we're left with x plus 2. And I take out the minus 1, we're left with x plus 2. And that's simply 3x minus 1, x plus 2. Now, bringing this factorization back into the initial bad boy right here, we have the limit as, so this just equals the limit as x approaches minus 2 of 3x minus 1, x plus 2 all over x plus 2, and there you go, the x plus 2's cancel out, and we're left with 3x minus 1. I sub in minus 2, minus 6, minus 1 equals minus 7, and there's our answer.